Do you know what lies at the edge of our very own universe? For centuries, humans have been fascinated by the mysteries of the universe. It required the best equipment to study some of the oldest objects or formations. Enter the James Webb Space Telescope, which has shaken the astronomy world since its launch in 2021. But something terrifying has just been detected at the edge of the universe by the James Webb Telescope. Let's find out what has been revealed that left scientists in a shock. James Webb Telescope is the largest telescope with infrared capabilities to detect light through cosmic dust and clouds. It has given new insights into the universe's fascinating origins with its groundbreaking technology. It has helped scientists explore the formation of galaxies and the search for extraterrestrial life. Recently, James Webb Telescope has taken a new image of the edge of the universe. It has sent shockwaves among scientists as it can alter our perception of reality. Let's discover what James Webb Space Telescope found at the edge of the universe and how the newest clicked image can change astronomy. James Webb Telescope is helping us unravel the universe full of secrets and marvels that exceed our wildest imaginations. Galileo Galilei, the father of the telescope, would be proud of how far we have brought his craft. However, progress comes at a steep price: $10 billion and many panicky moments during the launch. The James Webb Space Telescope can view the edge of the universe, allowing scientists to study some of the oldest objects and formations that have existed for billions of years. This powerful telescope has already revealed astounding insights about the universe that have left scientists reeling. By detecting infrared light, the JWST has given us an image of a galaxy cluster and a distant galaxy called MAX 0647 JD, allowing astronomers to understand better how galaxies evolved in the early universe. The JWST has also discovered some of the most ancient galaxies, including Glass Z12, captured 350 million years after the Big Bang. In July 2022, the James Webb Telescope released its first images of stars, galaxies, and an exoplanet. It provides fresh insights into galactic interactions that drove galaxy evolution in the early universe. SMAX 0723 was the first image captured by the James Webb Telescope, displaying a group of galaxy clusters that acted as a magnifying glass, allowing the telescope to capture and study distant objects behind it. The JWST also revealed other fascinating objects, such as the Sears 93316 galaxy candidate, which formed 250 million years after the Big Bang and set a record redshift of Z=16. Sears 93316 is a galaxy candidate discovered through the Cosmic Evolution Early Release Science Survey or SEERS program, specifically designed for imaging with the James Webb Space Telescope. Scientists are currently confirming the redshift through spectroscopy, which is why it is still referred to as a candidate. However, based on the imaging data from the JWST's primary imager, the NIRCam, the study has already ruled out the possibility of Sears 93316 being a low-mass star or an unobstructed active galactic nucleus. The telescope's observations opened a new frontier and helped us understand how it all began. While Glass Z12 and its companion are just a tiny portion of the size of the Milky Way, they generate stars rapidly and have a spherical or disc-like shape. It has defied astronomers' previous theories about the formation of galaxies. Despite the chaos of the universe, these galaxies have maintained a sense of order. Additionally, the telescope's observations of the Carina Nebula, 7,600 light-years away, revealed formerly invisible areas of starbirth. The JWST also detected an exoplanet unlike any other, which turned out to be a brown dwarf. This celestial oddball emits a dim reddish glow due to the modified form of fusion that occurs on massive objects, but is too tiny for hydrogen fusion. Webb also discovered silica clouds surrounding this little guy, which had never been seen before. These observations push us back to the time of the Dark Ages, when the first galaxies in the universe were thought to be forming before any of the stars we see today even existed. One of the great galaxies, Abell 2744Y1, estimated to be 13 billion years old, is the most exciting object in the universe. This timeline challenges astronomers' theories about how and when the first galaxies formed. The structure of the two galaxies, including Sears 93316, turned out to be calm and orderly, which was unexpected given the chaotic and crowded nature of the early universe. These galaxies are so bright. One possibility is that they contain a lot of low-mass stars, similar to the types of galaxies that formed later in the universe. Another possibility is that they contain smaller galaxies with fewer but extremely bright stars, known as population 3 stars. These stars contain hydrogen and helium and are believed to be the firstborn cosmos. So far, no population of 3 stars has ever been spotted within our local universe. Telescopes like the JWST can help scientists return to the first population of 3 stars. The JWST continues to set records within the short time it fully functions. The telescope can also identify atmospheric chemicals in relatively young and small exoplanets, including water, methane, carbon dioxide, and potassium. Webb has identified turbulent vertical mixing in the exoplanet's atmosphere, suggesting that carbon dioxide from deep down is being dredged up to mix with the methane high up in the atmosphere. The Phantom Galaxy is another elusive object in the night sky, but its brilliance is dazzling when captured in infrared with the James Webb Space Telescope. Researchers have created a composite image that showcases the galaxy's spiral structure by combining images from the Hubble and Webb telescopes. This image is part of an international project called FANGS that captures 19 nearby star-forming galaxies in the infrared. These crystal-clear Webb observations will revolutionize our understanding of these fascinating galaxies. The galaxy known as Able 2744Y1 is quite a fascinating discovery. It enables us to see the galaxy as it was 650 million years ago when it was only 8 billion years old. This discovery was possible due to 3 telescopes, Spitzer, Chandra, and Hubble. These telescopes collected data from various wavelengths of light. Using gravitational lensing, the team could capture an image of the galaxy. Despite its size, Able 2744Y1 produces stars 10 times faster than ours. It is about 50 times smaller than our Milky Way galaxy. This star production rate is typical of galaxies in the young universe. Scientists have tried to measure the size of the universe. They have discovered the universe has a radius of 46.1 billion light-years. There is much more beyond the observable universe. The observable universe was like a hot soup of particles following the Big Bang. The James Webb Space Telescope has observed 6 enormous galaxies between 500 million and 700 million years after the Big Bang. It is an unexpected discovery because they were as mature as our own, and it was previously thought that only tiny baby galaxies existed at this time. The galaxies appeared as sizable points of light. The amount of mass discovered means that the known mass of stars at this period of our universe is 100 times greater than previously thought. It has altered the prior theories of early galaxy formation and forced scientists to rethink galaxies' evolution. The researchers studying Titan with Webb were ecstatic and hoped that further data would help them map Titan's haze and unlock the secrets of this unusual moon. Evidence of an edge to where inflation occurred may emerge in the future, but there could also be numerous other universes out there like ours, following the same laws of physics and physical structures. It raises the possibility of complex life in one of these many worlds. Additionally, there should be a finite size to the bubble where inflation ended, with an exponentially massive number of such bubbles contained within the larger inflating spacetime. Traveling to the far reaches of the universe, we arrive at the most distant galaxy ever spotted by humans, GNZ11. This celestial beauty is located a staggering 32 billion light-years away from our planet, and accounting for the expansion of space, we reach a mind-boggling 46 billion light-years away from Earth at the surface of the last scattering, the birthplace of the first scattering of light and the edge of the observable universe. If you found this video insightful, don't forget to hit that subscribe button. James Webb Telescope is helping us untangle unknown mysteries of space. It has recently gazed toward 2 colliding galaxies called IC 1623 and witnessed something truly amazing. Due to Webb's advanced technology, we can observe galaxies about 270 million light-years away. It has revealed an area of intense star formation, with stars being produced at a rate 20 times faster than in our galaxy. The new image also revealed a previously unexplored layer hidden behind the dust, causing intense infrared radiation that produced Webb's typical pointed star diffraction pattern. With its ability to capture excellent images and provide crucial data that may hold the key to finding extraterrestrial life, the Webb telescope is undoubtedly a game-changer for space exploration. For more exploration of the cosmic world, click on the video links popping up.